Okay, so this is the last one we will do. So what I'm going to do is I'm going to go x squared plus 15 over x plus 3 squared, x squared plus 3. Okay, so this has the same thing going on. It has repeated factors and it also has a quadratic. So if I break that down, I get a over x plus 3 squared, b over x plus 3 to the first, and then cx plus d over, like that. Okay? All right. Let's get going. Okay. So what we're going to do now, notice that this is just a because this actual factor is linear. It doesn't matter that there are two of them. Okay, it matters that the factorization is a linear factorization. This can't go down any further than a square, so its numerator has to be linear. All right, let's try this out. We're going to multiply through. All right, here we go. Okay, so this whole left side, the bottom cancels out, so I am left with x squared plus 15. Okay, on a, all right, I am left with, again, I'm just canceling. Now I am skipping some steps with this one. Okay, b. And then last one. Okay, we're just multiplying through. Okay, well, it looks like I have a lot of multiplying to do. So if you would please be patient with me while I do that, that would be fabulous. Here we go. Gotta give myself a lot of room here. So first we'll multiply the a. Okay, now we're going to multiply the b. This might take a bit. Okay, and then we're going to do this in small little steps. We don't want to make a mistake. Okay, next step. Okay, all right, now this one's going to take a while. Okay, so let's see here. Cx cubed, 6cx squared, 9cx. Okay, now let's multiply through by d. Dx squared, 6dx, 9d. Whew. Okay. All right. So let's start by matching everything up. Okay, here we go. Now, first, what I'm going to do is I'm going to take a quick scan. And I notice I have cubics here. So let's match those up. Now, notice that there are no cubics on the left-hand side. So that means 0 is equal to bx cubed plus cx cubed. All right. Well, let's match up the squares. Okay, so I have ax squared, 3bx squared, 6cx squared, and oh wow, dx squared. Okay, and that matches up with 1x squared over here. Got to make sure you get them all. Okay. Now we're going to match up the x's. So let's see here. There's no x on the left, so that means 0. 3bx, 9cx, 6dx. Okay. Now let's match up the constants. Okay. So I have 15 on the left is equal to 3a, 9b, and 9d. And double check that you got everybody, and I think we did. Okay, so the simplest equation here is actually this one. Okay, so that first equation actually tells us that b is equal to negative c. Okay, so that means I can take all of my b's and replace them with a negative c. Okay, so let's try that. So on this first one, okay, so what I'm going to do is I'm going to divide out my x squares. So it's going to be 1 is equal to a x squared minus 3c, because b is equal to negative c, plus 6c plus d. All right, and then on this one, which equals 0, we get 0. Again, I'm going to divide out all my x's. B equals negative c okay. And then, again, b equals negative c, so 15, 3a, negative 9c, plus 9d. All right. Well, now looking at that, you might say that's not any better, but that's actually not true. That is actually a little bit better, because I can take this one and rewrite it as 0 equals 6c plus 6d. Okay, so if you think about that, that means that c, negative c, is equal to d. So we actually have a nifty little equality going on here. So if I look at this, and I look at this, so that tells me that negative c is equal to d, which is equal to b. So now all of my d's can be replaced with a negative c. Okay, so let's see whether that takes us. Let's just see where it takes us. Okay, so now I have top equation 1 is equal to ax squared minus 3c, I'm going to keep the c, plus 6c negative c. Now remember, d is equal to negative c. Okay, I kind of already used this middle equation right here. Now we're going to go down to the 15. Oops, I forgot an x squared. So let's get rid of that. All right. So 15, 3a minus 9c minus 9c. All right. Well, let's simplify those, see what we get. So let's see here. We got 1 equals a plus 2c. That's not bad. That doesn't look bad at all. And then 15, 3a minus 18c. So now I have a system of two equations with two unknowns. That's a little awesome. Just a little bit. Okay, so now what I'm going to do is I'm going to use substitution to help me out. Or elimination. Let's go elimination. So I got, let's multiply the top one by a negative 3. So let's do this. So c is equal to negative 1/2. Okay, now remember, negative c is equal to d, which is equal to b, which tells me now we have d, b, and c. Now all we need is a. Let's see here. So, I'm going to get a fraction, but that's okay. All right, so let's use 1 equals a plus 2c. Like that. Oh, look at that. So a equals 2. Okay, so now I know a equals 2, b equals 1/2, c equals negative 1/2, and d equals 1/2. All right, so now gotta go all the way back up here and remember how I wrote it. Okay, so we wrote it as a over b and then cx plus d, just like that. Okay, so let's plug it in. So 2 over x plus 3 squared plus, okay, so I can write this a couple different ways. You can just go straight 1/2. I'll show you a cleaner way to write it in a minute. Okay. And then whew. All right, so let's clean that up. Okay, because I don't want to write something like that. All right, here we go. So if, believe it or not, this is 1/2 divided by x plus 3. So I can actually rewrite that as, I won't spend too long on the rewrite, but here it is cleaned up. Okay, and then I can factor out a negative 1/2. Oops, kind of messed up there. Hold on. And there we go. Well, that was fun. Well, at least I thought so, but you guys know I'm weird. All right, so I hope you enjoyed that. That's probably the most difficult thing you'll see. All right, hang tight.